All right, let's get into it. Today, we are taking a trip to the most extreme, most mysterious places in the entire cosmos, black holes. But I need you to just, for a moment, forget everything you think you know. Forget the sci-fi movies, forget the cartoons, because we're about to completely rewire how you see these things. So let's just start with this one, kind of wild question. What if the most destructive thing we can possibly imagine in the universe isn't really an ending at all, but instead it's a one-way ticket to an unavoidable future? Just let that sink in for a second, because that idea, that's the key to all of this. First things first, we have got to bust the biggest myth out there. You know the one I'm talking about. The idea of a black hole as this giant cosmic vacuum cleaner, just sucking up everything in its path. Well, the reality is, it's a lot weirder and honestly a lot more terrifying than that. Here's the most important distinction you can make. A black hole doesn't suck. I mean, if you're far away from it, its gravity is exactly the same as a star of the same mass. The real danger isn't that it's some thing that sucks you in. It's a place that traps you. It's not really an object anymore. It's a region of space-time that's been twisted so violently that the very rules of reality start to change inside. And this gets us to a concept called a causal trap. See, once you're inside, it doesn't matter how fast your ship is or how powerful your engines are. Every single possible future path you could take, they all lead inward to the center. The only way out would be to literally travel backward in time, to break the fundamental law of cause and effect. It's not a trap for spaceships. It's a trap for causality itself. So, okay, let's imagine we're traveling right up to the edge of this trap. This is the place that science fiction has made famous, right? The boundary from which nothing, not even light, can ever escape. We are now arriving at the event horizon. And the thing to wrap your head around here is that the event horizon, it isn't a physical thing. You couldn't touch it. It's really a boundary of information. Think of it like a one-way door in the universe. The second you cross it, anything you do, a flash of light, a radio signal, your own existence, is permanently and totally cut off from the rest of us. You can never again influence the outside universe. Ever. And this is so key to understanding what it would be like. You wouldn't smash into a wall or feel some kind of jolt. Actually, for a big enough black hole, you wouldn't feel anything special at all as you drift across. It's just an invisible, imaginary line in space, but its consequences are absolute. You just don't realize it until it's too late. And here's where it gets really, really weird. All thanks to Einstein's relativity. For you, the person falling in, your watch just keeps ticking normally. You'd sail right across the horizon without noticing a thing. But for us, watching you from a safe distance, we'd see your clock start to slow down, slower and slower, until it seemed to stop completely. To us, you would look frozen at the edge of the black hole for all of eternity. And the craziest part? Both of those views are completely correct. Time itself isn't absolute. Okay, so we've done it. Let's say we've crossed that invisible line. We are now inside the black hole. And this is where the very fabric of reality, the geometry of space-time, gets completely scrambled. The basic difference we all understand between space and time, well, it collapses. This right here is probably the single most important, most mind-bending idea you need to grasp to understand what's going on. Out here, where we are, you can move any which way you want in space. Up, down, left, right. But you are forced to move forward in time. You can't stop it. Well, inside a black hole, those roles literally swap. So, what on earth does that mean? It means that moving toward the center, toward the singularity, it's not a choice anymore. It becomes as unavoidable as Tuesday following Monday. You literally can't stop yourself from moving inward any more than you can stop yourself from moving into next week. The center of the black hole stops being a place you can try to avoid and becomes a moment in your future that you are absolutely destined to meet. So, what is this destination then? This singularity at the center? Well, it's not a tiny, infinitely dense little dot like you might imagine. It's something much more profound. It's the exact point where our entire understanding of the universe just completely and utterly breaks down. You see, whenever our best theories, like general relativity, start predicting infinite values for things like density or gravity, that's not physics telling us that a real physical infinity exists. No, that's physics basically screaming at us, throwing up a giant error message saying, this theory doesn't work here anymore. You need something new. So the real takeaway is this. The singularity isn't a place you actually arrive at. It's the hard limit of what we know.
It's like a giant signpost in the cosmos that points towards a deeper, more fundamental theory of physics that we haven't discovered yet, probably some kind of theory of quantum gravity that can finally tell us what's truly going on at the heart of a black hole. But the mystery doesn't stop there. Not even close. In fact, black holes create what might be the single biggest paradox in all of modern physics. They set up a battle royale between our two greatest theories of the universe, a real fight to the death. And here's the fight. On one side, you have quantum mechanics. One of its absolute bedrock principles is that information about something can never, ever be truly lost from the universe. But on the other side, you have black holes, which seem to do exactly that. They swallow things up with all their intricate details, and then Stephen Hawking showed they eventually evaporate away, leaving behind nothing but boring, featureless heat. It seems like they just delete information from reality. One of these two ideas has to be wrong. And trying to solve this paradox has forced physicists to come up with some of the wildest ideas you can imagine. I mean, is all that information somehow painted onto the two-dimensional event horizon, like a giant cosmic hologram? Or maybe it leaks back out in some incredibly subtle way over billions of years? Or does the answer require a complete revolution in how we even think about space and time? We just don't know yet, but the search for the answer is what's pushing science forward. So, we've been on this very personal, inward journey into a black hole. But now I want you to pull your perspective way, way back out. Because it turns out these things aren't just cosmic dead ends. Far from it. They are actually fundamental engines that build and shape the entire universe we see around us. Here's the beautiful irony. The absolute darkest things in the universe are responsible for creating some of the brightest lights. As gas and dust get whipped around into a frenzy before falling in, they heat up to millions of degrees, creating quasars that can outshine entire galaxies. They launch these unbelievably powerful jets of energy that can either kickstart star formation or shut it down completely. They literally sculpt the galaxies they live in. They're not destroyers, they're architects. And this is really why they are so incredibly important to science. Black holes are the ultimate laboratory. They are the one place in the cosmos where all of our greatest theories, gravity, quantum mechanics, information theory, you name it, are all forced into the same room and have to figure out how to work together. So to really understand a black hole is to understand the deepest connections woven into the fabric of reality itself. In the end, this is maybe the most profound way to think about them. Black holes aren't just these weird, exotic objects floating around out there. By pushing our theories to the absolute breaking point, they act like a mirror. They reflect back to us the limits of our own knowledge, and in doing so, they show us the path forward, towards a much deeper understanding of what reality even is. Which leaves us with the ultimate question, doesn't it? The one that black holes practically force us to ask. We tend to think of space and time as the absolute foundation of reality, right? The stage where the whole cosmic play happens. But black holes show us that this stage can bend, it can break, it can even swap roles. So, if space and time aren't the most fundamental things, what is?